I am Amna Mazen. Today will present intersection mobility for Polaris car paper with co-authors Dr. Mariam Fayed, Dr. Mohan Krishnan, Dr. Otaiba Muhammad, and Dr. Mark Paul. The agenda today is first I will talk about background and the objectives of the paper. Then I will discuss the proposed algorithms. Then I will talk about the simulated environments and our results. Finally, I will make a conclusion and talk about future work. For the problem background, as we all know, intersection mobility is one of the most challenging tasks for autonomous vehicles. This paper comes to satisfy the need of my university to participate in the Intelligent Ground Vehicle competition in June 2020. According to the IGVC rules, the car should go through the lane, then it will turn right or left and merge into the suitable lane and will drive through this lane until it detects a barrel within 3 feet. So this paper proposes two algorithms to solve this problem. The first algorithm will depend on LiDAR data if we don't know the curvature radius. The second algorithm will generate fifth-order Bezier curve if we know curvature radius. Both algorithms have been tested in multiple simulation environments in gazebo. The car used in this paper is Polaris car with maximum speed of 25 miles per hour and maximum steering angle of 45 degrees. LiDAR used in this paper is SICK LMS 511 LiDAR, which covers 190 degrees from -95 to +95. This LiDAR emits 760 data points covered by 76 sectors. The left and the right regions will cover 25 sectors, whereas the front region will cover 26 sectors. The first algorithm will depend on LiDAR data. First, we will choose desired distance to keep between the car and the curb. And as the car drives, the LiDAR data will measure the actual distance. And the difference between the actual distance and the desired distance will be the error. Then the car will steer right and left to eliminate this error. So steering angle will be calculated based on this error. Then it will be checked that it didn't exceed the maximum steering angle. And if the car detects a barrel in the safe distance of 3 feet, the car will stop. The second algorithm is based on that we know the curvature radius, so we can calculate the coordinates of the entry point of road intersection and the leaving point of the road intersection. Based on this, we can generate fifth-order Bezier curve by joining two cubic Bezier curves. In this case, the path will be provided to Polaris car as a list of waypoints. Simulated environments. In this paper, the simulated environments is constructed to mimic the IGVC environment with 8 feet road width. The simulated environments are classified into static and dynamic environments. We mean by static is that there is no nearby cars in the adjacent lane when the car turns right or left. And we mean by dynamic environment that there is some nearby cars in the adjacent lanes to the departure or arrival lanes when the car turns right or left at road intersection. To conclude, this paper proposed two algorithms to solve the intersection mobility. First one will depend on LiDAR data when we don't know the curvature radius. The second one will generate fifth-order Bezier curve based on the curvature radius. And these algorithms were tested in multiple simulation environment in gazebo. For the future work, we plan to test these algorithms on the real Polaris car, and we also plan to replace the 2D LiDAR with 3D LiDAR. Here is the most important references that we used in our paper. Thank you for your attention.